Good evening. And welcome to the third in our series of talks that have been arranged by our faith formation group at St. Michael's. It's wonderful to see such an incredible turnout tonight. But obviously your guys' subject has grabbed the imagination, so that's super. I'm sure some of you, as I have done often, on a bright starry night, have looked up at the sky and been overwhelmed by these billions and billions of stars that are billions and billions of light years away from us, and been struck by one seeming insignificance, and asked the question, where do we find God in the universe? And we're very privileged tonight to have two visiting Jesuits, but distinguished astronomers who have been in Cape Town for the last week for an international conference, Astronomic Union, yeah? International, yeah. To address this very topic. So, Brother Guy, yep, notwithstanding his Italian surname, which I'm not going to try and pronounce.
One of the big name speaker, and mine has 11 letters.
Yes, just there's a red button at the bottom, yeah. So Brother Guy was born, notwithstanding his Italian surname, was born in Detroit, Michigan. Studied planetary astronomy at the Massachusetts Institute of Technology in the University of Arizona, speciality in meteorites and asteroids, and then along with more than 250 scientific publications, he's the author of several popular books on astronomy, and I think I did mention he is the director of the Vatican Observatory. And then Father Jean-Baptiste, I'm also not going to try and pronounce your surname, has been at the Vatican Observatory since 2010, has a master's degree in mathematics, University of Namur, Namur in Belgium. And he has a PhD in astronomy from the University of Western Ontario in Canada. And his fields of research are mainly asteroids and meteors. So the format, very simply, they're going to talk to us. And at the end of that, we will open for a session of questions. And I will talk a little bit more about that at that time. So who's going first? Brother Guy.
I think we'll just use this one and then pass it back and forth. And that way I won't be interrupting him when he's speaking. So as I mentioned, my Italian name is Consolmagno, and that was my great-grandfather who left Italy in 1899. You can tell from the gray hair, I'm a classic baby boom kid, which meant that the year I started kindergarten was the year that Sputnik was launched. My last year of high school was the year that people landed on the moon. So how could you not be crazy about space? And I was. When I went off to university, I originally didn't know what I wanted to be. Maybe a journalist like my father, maybe a lawyer like my grandfather, maybe a Jesuit like the Jesuits who had taught me in high school. I had no idea really because I wanted to learn everything. I was a nerd. No, that's not true. I am a nerd. So I went first to Boston College, and I don't know what it's like if those of you who deal with students now, but when I was a student, there was a tendency for freshmen at university to do a lot of drinking. And then they would be very foolish and do foolish things. And then their lives would fall apart and they'd pour out their troubles on me because I didn't drink for the very simple reason that the stuff tastes terrible. And I could use all that money on chocolate. So when they would pour out their troubles, all I could think of was, well, you're idiots. Of course your life is miserable. Why are you telling me this? In order to get away from the kids in my freshman dorm, I went to a Jesuit, because I was at Boston College, the Jesuit University in Boston, and said, I want to become a Jesuit. And he said, why? To get out of the freshman dorms. That's not a good reason. Well, I can't stand being around these kids with problems, and all I can think of is they're idiots, and that's why they have problems. And he goes, that's not good pastoral care. Indeed, sometimes people who are not idiots have problems. And indeed, sometimes, even if you have problems because you're an idiot, you still need somebody to look after you. None of that sounded appealing to me at all. But my best friend from high school was at MIT, where they had the world's biggest science fiction collection. So I transferred to MIT to read science fiction, but wound up in the Department of Earth and Planetary Science, which was the geology of other planets. And I discovered there are things called meteorites, which are rocks that have fallen from outer space and you can pick up and hold. It's like a religious relic that reminds you that these people were real people. The meteorite is a scientific relic to remind you that outer space is real and not just something you see on a TV screen. This fascinated me, and I went off and did my doctorate studying meteorites and the origin of the solar system and dust and all sorts of fabulous things. And I had 5 years as a postdoctoral fellow back in Boston. Are there any academics here? Do you know what 5 years as a postdoctoral fellow means? It means I couldn't get a job. So I decided science was worthless. That Jesuit conscience said, why am I worrying about meteorites when people are starving in the world? So I decided to quit science. I was 30 years old, and I could not imagine being older than that. I quit my science, I joined the US Peace Corps, and they sent me to Kenya. So I lived 2 years in Kenya, thinking that I would be working with people who were starving, and instead they sent me to the University of Nairobi to teach astrophysics to graduate students. But what I learned from the Kenyans, and indeed what we've learned this week talking to all of the astronomers from around the world, is that looking at the sky and asking questions about what's up there. How many people here have ever seen the moon through a small telescope or a pair of binoculars? How many of you have ever seen the rings of Saturn through a small telescope? How many people have ever seen the rings of Saturn and not gone, oh, wow? I had a little telescope, and everybody in Kenya went, oh, wow. And started asking these questions that Father was mentioning. Who am I, and how do I fit into all of this? Now, at the time when I was in Kenya, I had a very clever cat. Much better at being a cat than I could ever be. But my cat never wanted to look through a telescope. It's only human beings who are hungry for more than just, where's the can of tuna? Who are hungry for more than just, where can I get another coat to wear? Though those are important, they're also hungry to feed their souls. We don't live by bread alone. I'd read that someplace. And that means that studying the universe is one of those things that makes us more than just a clever cat, that makes us human. I was so excited to share this that I came back to America, did get a job teaching, and I thought, I would love teaching this stuff. I will join the Jesuits. I will go to a Jesuit university and teach astronomy for the rest of my life. Well, as a Jesuit, I have 3 vows. Poverty, I'd been a graduate student. I was used to that. Chastity, I'd been a graduate student. I was used to that. Obedience, that I was not used to. under obedience, the Jesuits ordered me to go to Rome, live in the Pope's summer palace, look at that ugly scenery, eat that terrible food, and do whatever science I wanted at the Vatican Observatory, where I discovered that they had a collection of 1,000 meteorites. Remember meteorites? Remember how exciting it was? That's what I've been doing for the last 30 years. And 10 years ago, for my sins, Pope Francis made me the director. That was my route. It was sort of my hunger that drove me. And when I arrived, Father George Coyne, who was the director, ordered me, "This is your job at the Vatican Observatory. Do good science." Because the reason the Pope established an observatory 130 years ago, 135 years ago, 1891, Pope Leo XIII, was to show the world that the Church supports science. And as Pope Pius XI and Pius XII said, astronomy inspires these religious feelings in us. And as Pope John Paul II said, faith and reason, science and religion are tools that direct us towards the truth. And these are ways, these are places where we can encounter God. So that's my little story. Jean-Baptiste, how did you become an astronomer? Where did you wind up here?
Okay, thank you. Very easy. I'm from Congo, Democratic Republic of Congo. And as a kid, so I was actually going to a Jesuit high school. And the Jesuit high school, so I was spending all my time with the Jesuit. So I was going there in the morning, and then I was going home only in the evening. So all day long, I was with the Jesuit. And then what I did, at high school was mathematics and physics. So we have an option in science, math and physics. So I did mathematics and physics. And then after that, I don't know if it is because I was with the Jesuit, so I had a call, to become a Jesuit myself. And then I was sent, for 2 years in Rwanda for the first, 2 years of our formation as a Jesuit, what we call a novitiate. So I did a novitiate in Rwanda. And then after that, I was sent back to Kinshasa, to Democratic Republic of Congo, to do philosophy. And then after that, because I did very good mathematics, and then my province needed people to teach mathematics in our high school, so we did have 9 high school at that time. And then my provincial said, I need you to do mathematics so that you can go and become a teacher of mathematics. I said, okay, by obedience, I'm going to do just that. And then I was sent to Belgium to do mathematics. So I went, I did mathematics. But I don't really know why actually get me into this kind of astronomy in mathematics. What we call celestial mechanics is about dynamics of celestial bodies. So I did it, because really I was really good at that, and then I really love it. And then I came back home, expecting that I'm going to be teaching mathematics in one of our high schools. And then there was a call from the Vatican Observatory. So at the Vatican Observatory, they were getting old, old. They were getting old, and then they wanted actually new young people to come and then start actually to replace all these old people. And then there was a call, and that call was, if in the Society of Jesus, in the world, so there are young people who are really interested in astronomy. they can actually come and then join the Vatican Observatory. And I didn't know that until my provincial, who did actually receive that call, called me, and then, and then said to me, didn't you do astronomy in Belgium? And I said, yes, I did a kind of astronomy. Okay, listen, here is a call from the Vatican Observatory asking for young people to go and work with them. Why don't you go and stay some time with them and then see if really you will fit in what they are doing? And then I said, okay. So I went to Italy, and then I stayed 6 months with the Jesuits, the astronomers, like Guy actually was there, and so other astronomers, old, I mean, some actually of them are not with us today. And I stayed with them, and then actually I observed what they were doing, and then truly, actually, I find that, my field of research where actually I can contribute, I could contribute to the work of astronomy in the Vatican Observatory. And then from there, because I did only master degree in astronomy, so I needed actually to do PhD, doctoral studies. So I studied my doctoral studies in Paris. And my first research in astronomy was on asteroid. When I was introduced, they said that actually my field of research is meteors and asteroid. So I studied with asteroid, but not only this asteroid, but this kind of asteroid we call the binary system of asteroid, meaning that we have actually these rocks between Jupiter and Mars, yet some of them do have a companion. They are not that big, they are not planets, they are asteroids, but some of them do have a companion, evolving around them. So I studied actually this kind of asteroid, binary system of asteroid. It's very interesting now, 1 year or 2 years ago, because, we wanted actually to answer one question. What actually is going to happen if ever an asteroid is coming to hit the Earth? How are we going to protect the Earth from that? And then, there are many theories, and one of them actually was to send a probe, and impact the body, and then that body actually will just, miss the Earth, to, change the orbit. Yes, just, knocked it a little bit, and then that body actually will miss the Earth. I didn't know, and then, okay, here I am back to this kind of a project called DART, and to see if it truly it will work. And then there was, a system of, the binary system of asteroid, Dimorphos and the Dimorphos and then Didymos. The Didymos is the main body, and the Dimorphos was the satellite going around that. And then that project, DART, what they did was just that. Send a probe and then impact a little bit the satellite of, that system, and then see what we are going to have after that. So we knew the orbit, of the satellite around the main body before the impact, and then we needed now to know if anything actually changed after the impact. And then fair enough, it changed, the orbit of the satellite changed because the satellite was going around the main body in 3 hours, and then after the impact, now the satellite goes around the main body in 2 hours and a half. So that means there is a way to protect the Earth from an asteroid impact. But this is something, so maybe we'll come back to that later. So I did that. That was my first research in astronomy. And then I was sent to Canada to do PhD. And my PhD was on meteors. And then there also was very important. These shooting stars, flying around across the Earth atmosphere, a lot of them actually impact the artificial satellites. So it is very important now to know how actually to protect the artificial satellites, because you know that we rely on them for communication and all of that. And then how to protect them, how to build them, stronger, so that despite, the impact of meteors, they could actually survive. So this is the kind of work actually I did, as you can see, has something to do with us as a civilization, as a human being. So I'm going to stop there, and so maybe I'll come back about science and faith.
So you can see that astronomy is this marvelous mixture of looking at the sky just because we're amazed, and also looking at the sky for very practical reasons. Whether it's protecting us from an asteroid that's going to hit us, or protecting our satellites, or we both, as it happens, both of us study asteroids. It's just a coincidence that those are the two of us who are here. But you can study asteroids as relics from the beginning of the solar system 4.5 billion years ago, because they're basically untouched. We can tell what was happening when the solar system was being formed by looking at these rocks. Or we can look at them because they're a threat. Or we can look at them because they're a source of mineral wealth. Someday, people are going to be living in space, and they will go to the asteroids to extract. Do you know what the most valuable thing that you can extract from an asteroid might be? There's a lot of them that have iron, and there's more iron in one small asteroid than we use in 1,000 years on Earth. And there's platinum, and there's gold. But you know what the most valuable thing in the asteroids? Water. You can take an asteroid, and with the water, you could extract it to make chemical fuel for your rockets, or oxygen, or water to breathe. All of these are both very practical reasons, and yet, notice what he started with and what I started with, that we loved this stuff. And we did this work because we loved it. So when we come to the question of finding God in the universe, one of the places where we find it is in that sense of joy that we have looking at the stars, and the sense of joy that we have when we understand the stars. I'm reminded, I did teach a little bit when I took a sabbatical year once to teach at a university, Fordham University, and I had a very, very bright student. I was teaching electricity and magnetism, and I was going through Maxwell's equations, so already half of your eyes have glazed over. The other half will glaze over here. I'm writing the equations on the board in the differential form, and you take the derivative of this with respect to time, and the derivative of that with respect to space, and you put together all the like units, and you come up with a second-order differential equation with a whole bunch of terms on how the electric field changes with the change in time is like the way the electric field changes with its change in space. And now I've lost all of you, except for the kid sitting in the front row. Of course, the best students always sit in the front row. I don't know if sitting in the front row makes you a good student, or it's just the ones who are least scared are the ones who sit in the front row. But anyway, he was sitting in the front row. And he looks at that equation. And before I can say anything more, he goes, oh my God, it's a wave. Yeah, huh? These equations that Mr. James Clerk Maxwell put together in 1865 explain what light waves are, explain what radio waves are, explain how you can use alternating current to transmit power across, explains how you can put together electronic chips, everything that we know about electricity and magnetism and anything that runs on electricity and magnetism starts with these equations and the fact that, oh my God, it's a wave. And even as astronomers, when we look at the light of a star and we see that you spread it out into its color, into its rainbow, and certain colors are missing because the electric wave has interacted with the electrons in a particular kind of element or a particular kind of molecule, and thus from a very, very long distance, I can tell you that that star Sirius has these chemicals present and those chemicals missing, even though I've never been there. And it all comes out of Maxwell's equations, and oh my God, it's a wave. And that student appreciated it. I still remember it because I've never had a student that good before or since. But it was that, oh my God, it's a wave, that makes you want to do the science. It's that moment when you feel God tapping you on the shoulder and saying, did you see that? Isn't that really wonderful? Let me show you the next one. When I was a child, I remember I was growing up on the shores of Lake Huron in Michigan in the summertime, and it was a rainy day. There was nothing, couldn't go out and play, and so my mother brought out the playing cards, and we were playing rummy. And I maybe was 9 or 10 years old, and she's playing and I'm playing, and it's a fairly simple game. But you know how little kids every now and then have a flash of adult? And as you get older, there's longer and longer flashes. A friend of mine who's raised 2 teenagers says teenagers are not half as mature as adults. They are entirely as mature as adults half the time. And the other half the time will look out. So I had that tiny moment of an adult insight. Why is my mother playing cards with me? She's a grown-up. I'm a kid. She could win this game anytime she wanted to. She's playing with me because she loves me. Why does God give me the ability to play these wonderful games in this universe that He's put together? It's His way of telling me He loves me. That's where I find God in the universe. See if you can top that one.
So the question actually I like to answer before you is this one. Does being scientist, being scientist bring me close to God? So I am a Jesuit, I am a priest, I'm Christian, and then you may say, okay, being a Jesuit actually is good because you are a Jesuit, so you deal with God, so God is with you. And then being a priest, you may say, okay, it's good because being a priest, God is always with you. But being a scientist, does God, the presence of God is there, yes or not? And this is the way actually I would like to answer this question. I will say this. It is not because I read the Bible that I know God. It is not because I go to church that I know God. It is not even because I pray that I know God. So between all these facts, reading the Bible, someone actually will put, the immediate link between reading the Bible and God. But it's not that obvious. between reading the Bible and God, there is a gap there. And then that gap needs to be filled by what we call grace. And then that grace is actually, oh, I didn't know that. Oh, God is good. Oh, that is grace. And then it is only because we reach that point that we benefit from that grace that now we can truly feel that we are with God. And then all our life, what we are doing is to reach that point of grace. And then now we can say, I know God. And then I can talk about God, not because I have read the Bible, but I can talk about God because I got that grace. And then I know God from inside because I did have experience of God himself. And then now when we go to science, brothers and sisters, it is going to be exactly the same thing. So I'm doing science. I go to the lab and then all of that, and then I got the result. And then what between doing science and then God, something actually need to come there. And then that, so now I feel I'm connected to my Maker. Now I really feel that God is there. But for that to happen, we need to do science. Listen, it is not only about science, about anything anyway. So we do things, years after years and then a decade after decade until that grace will come. And then we'll say that, what have been done? All my life, what I've been doing all my life, actually God is in it. So now the question is, how do actually I come to relate myself to God through science? Is by doing science day after day after day after day until I'm going to get that grace. Like a guy's student. That is very important in our life. And then I say, we do it only with science, but with anything actually we deal with in our life.
I'll end up here with a couple of comments to build on that, and then we'll open it to questions. But what have I learned specifically about God since I'm a scientist? Notice that doing science means looking for truth. There are things that I could make a claim about. I observed a comet and I saw these 12 marvelous things, and since that comet is long gone, nobody can check me. I could make up anything I wanted and be famous, but I know I'd be telling a lie. That would not be science. I could come up with some marvelous calculation that no one's going to be able to repeat until I'm dead to find out that I cheated. But that wouldn't be science. That would not satisfy me. That would not satisfy an atheist. But then an atheist is someone who only believes in one less God than I do. Because there are many ideas of God that I think are wrong. I believe in only one God. But even, and in fact, most scientists I know are not atheists, so they would say they're agnostic, they're not sure. But none of us are sure. We make a commitment anyway. You could be married 50 years and you're still not sure if that person's going to not walk out tomorrow. We make the commitment anyway. I'm not sure I made the right decision to go to MIT, but I'm stuck with that decision. We spend all of our lives making these decisions, hoping that they're the right decision. So what has the decision of being a scientist taught me? First of all, that the universe is logical, that the science we do works. It brings us to the truth. That's profound. As I said, there are other gods out there I don't believe in. I don't believe in the God who throws lightning bolts just because he feels like it. That was the pagan god. And that God doesn't work. But the God of Maxwell's equations that explains to me why lightning goes the way it does, that works. And that's logical, and that's reliable. God is logical and reliable. But of course, we knew that from the description in Genesis, where God creates as logically as day follows night. That's what Genesis is telling us. God not only creates logically, but God creates beautifully. That the stars are beautiful and the equations that describe the stars are beautiful. And sometimes when you're trying to decide what's the best way to explain things, the hardest part about being a scientist is not the work you do, but finding a problem that's big enough to be interesting, but small enough that maybe I'll get an answer in my lifetime. And when you have to choose, how am I going to explore, you look for the way that seems the most elegant, the most beautiful, the one that gives you that sense of, oh, this is right. That's why a computer can't do science. That's why a cat can't do science. Only a human being can do science, because only we have both the logic and that sense of beauty. What else does science tell me? Well, at the very beginning in the introduction, you look at the stars and you wonder, they're so big and I'm so small. Is that a product of modern science that has told us how big the universe is? Should we blame modern science for making God seem far away? Read Psalm 8. The psalmist, 2,500 years ago, said exactly the same thing. Oh God, who are we that you even pay attention to us? You who have created this entire universe. And yet, you love us so much that we are little less than angels. You can look at the enormity of the universe and say, the universe is so big and I'm so small, how could God ever notice me? Or you can say, the universe is so big and I'm so small, how immense God must be that nonetheless God does notice me and you, I'm not sure about you, and you. I'll end with the story that those of us with gray hair may appreciate, and the younger ones, maybe you know what I'm talking about. About 10 years ago, I was looking for something totally different on the internet, and I came across an article written by, I think it was in The Independent or one of those British newspapers, written by the woman who writes their gardening column, a woman by the name of Emma Townsend. And instead of writing about gardening, she was writing about her childhood. When she was a little girl, she really had a wonderful relationship with her father. She was very close to her father. He was away on work a lot. So as a little girl, he was gone, and then, for months at a time, and then would come back. And every time he came back, this was like the most marvelous thing. And he was so happy to see her, and she was so happy to see him. To her mind, he was, a rock star, right? When she got to be about 11 years old, she realized that her father, Pete Townsend, really was a rock star. The lead guitarist for The Who. We are in that relationship with God. We know God as our Father, the one who we know intimately in prayer. And only through astronomy do we also realize that that same Father who we call Daddy is the one responsible, the rock star responsible for all of this. And what a wonderful place we are. So, any last words, or shall we go on to questions?
We can go to questions and then we'll come back to some comment. Comment.
Okay, so we're open to questions. I ask that you keep your questions direct and short. No homilies, sermons, or lectures. And how do you want to do this? Should we take a couple of questions and then you answer them, or do you want to do them one at a time? One at a time. Okay, who's got a question?
And we'll repeat the question here so that other people can hear it and it's recorded.
No questions? There's a question.
You talked about adjusting the orbit of the meteorite or the satellite. Did you work with NASA?
Oh, yes. We work very closely with NASA. We've had a couple of people who have done projects with NASA. Brother Bob Mackey, who works in our meteorite lab, was invited by NASA to come with his instruments to measure the samples from asteroid Bennu. But you particularly worked with NASA and told them about the project you did.
Actually, the project on the DAT, that was with NASA, as you can imagine. But also the project on meteors and the density of shooting stars. That also was a project with NASA, was financed by NASA.
We'll talk about observing the dart with the Vatican telescope.
Yes, so that actually occurred, and then now actually there was a follow-up, and use our telescope, the Vatican Observatory telescope, to do this follow-up. So to see truly if the orbit of the satellite actually has changed or not. So that was done with the Vatican Observatory telescope. Yeah.
I should mention that because of light pollution, we can no longer use telescopes in Rome. So about 30 years ago, we built another telescope, a modern telescope, in the mountains outside of Tucson, Arizona, where the skies are very dry and very dark. And that's the telescope that Jean-Baptiste uses. Jean-Baptiste has a magic affinity to this telescope. Every time he goes up, it rains. But on occasion, you do get good results, and you were a part of the team that was observing the Didymus pair with our telescope to be able to time how the orbit has changed.
One, two.
Hi, I know that NASA has, they do a tabletop exercise every year, usually on planetary protection. And they bring together specialists that look at if there were an asteroid, for example, hitting the United States, what would happen for immigration, for fraud, for communication, things like that. But they don't ever address the spiritual aspect. There's never a religious person in the room. Does the Vatican have a plan for planetary protection, or if there were an asteroid, like a communications plan? Is this something you think about?
No. Sadly. One of the things that happens when you become a Jesuit astronomer, and like me, I'd been an astronomer in the field 20 years, that my friends and colleagues come and tell me about things I never knew, like their religious beliefs. One of the people running that, in fact, is a devout Catholic. So it's not like there aren't, religious people in the room. But it's not the sort of thing that we've really thought through. A similar question comes up if the SETI Institute, which is listening for evidence of intelligent life, if they ever found something, would the Vatican have something to say? And the answer is no, we don't have anything cooked up ahead of time. In part, I think that's maybe not a bad thing because in the absence of the data, we don't know what we would say. And I'd like to see, of course, this being the Vatican, once we find it, it would probably take about 10 or 20 years. But I will say one of the roles the Vatican Observatory has in the field, we're astronomers with every other astronomer. We collaborate with them. Our collaborators get money from ESA, from NASA, from other government institutions. We publish in the same places. We do similar sorts of work. But being from the Vatican, we remind people of the religious aspect of what we do. And in some cases, I like to think, we remind people that the goal is not to show up the other guy, but to actually find the truth, which is not always an easy thing for scientists to remember.
Questions?
Thank you so much for your talk. I don't know if it's fine to ask 2 questions. Okay. The first question is, do you guys hire postdocs that are not priests or Jesuits? Because I'd be keen. And then the second is that because you've already mentioned telescopes, I'm just pretty curious with regards to how you'd maybe, if you have satellites, and also you talked about orbital mechanics. So do you kind of look at expanding the techniques that you use for, I guess, more Earth-centered work beyond just looking at satellites? Because I'm just presuming, since you are talking about Maxwell's equations, you're looking at partial differential equations, so it's your numerical solvers that could be applied to stuff like the Navier-Stokes or different types of PDEs or ODEs. And do you look at earth science, how that could help places, especially like Africa? That's my question.
Well, let me maybe describe a little more of who's at the observatory to give you a sense. We actually don't generally direct people to do one thing or another. The call is out for young Jesuits who are interested in astronomy, and they will get a doctorate in some tiny corner of astronomy, and it's luck of the draw. So at the moment, we have 12 Jesuits who are astronomers from 4 continents, speaking at least a dozen languages. I think that's just Paul Gabor himself speaks a dozen languages. He's from Central Europe. But the work we do ranges from the mathematics of quantum gravity and Reg calculus and things like that, which Gabriele Giunti does. We have several people who do models of galaxy interactions, both observing and then calculating the models. We have people who are doing spectra of stars, looking at peculiar stars, or spectra of clusters of stars to see how you can determine the nature of that cluster, even if there's a dust cloud between the cluster and us. People who are looking at the spectra of stars around which we are discovering planets, to people looking at the astrophysics of. But in addition to those dozen Jesuits, and you have to be a Jesuit to be at the observatory because they don't pay us enough that any human being could actually live on what they pay one of us. But when we combine 12 salaries under one Jesuit community, we can live okay. But in addition, we have a dozen adjunct astronomers. And you don't have to be a Jesuit. You don't have to be religious. We have 3 women in that group. We have a number of lay people in that group. And they are people who can use our facilities to do their astronomy and to inform us of the work they're doing, and also to spread the word to the world. Here are religious people, because even though they're not members of a religious order, they have to be Catholics in good standing and approved by the Vatican. But this is a way of just showing the astronomical world, and even more importantly, showing the people in the pews that science is a good thing. Science is a route to God. And any kid who thinks that they have to choose between religion and science is fooling themselves in a really sad way, because they're missing out on half of the fun, regardless of which one they decide to reject. About the specific work you're doing in orbits, do you want to talk any more about, are you still doing research in orbital and celestial dynamics specifically, or?
Yes, so I still work on that. I still work on that, but mainly now I work on asteroids. You know, the color of asteroid, the characterization of asteroid, but not only, you know, asteroid be in the main belt, so between the Mars and the Jupiter, but I mean those asteroids which really come close to the Earth, and we call it near-Earth asteroids. So I work on these kind of bodies, small bodies. And I keep actually working on the dynamic of solar system bodies. Yeah, yeah. But what I would like actually to add to, no, I mean, ask you a question. So you remember that one of your book is, should we baptize the aliens? So, so Guy wrote a book with Paul Miller, so was our superior in Rome. And then the question actually addressed in that book was, should we, that was the question, you know, would you baptize aliens? So what was your answer?
Only if they ask. Jean-Baptiste is a bit modest. His thesis work on observing meteors used some pretty heavy-duty mathematics to be able to determine from the height of the meteor, the brightness of the meteor, and how quickly it decelerated when it hit the Earth's atmosphere, to work out what they were made out of and connect that with the orbits and what part of the solar system they came from. So it's pretty heavy-duty mathematics.
Joy?
So you're asking about the research being done at CERN. Paul Gabor, the fellow from Central Europe who I mentioned, worked at CERN before he became a Jesuit. So we have connections there. And Gabriele Giunti, who's doing this work on quantum gravity, is also in contact with people there. We just had a meeting 2 months ago about quantum singularities. So we don't directly work with those people, and yet we're aware of their work insofar as what they're telling us about the very small scale, how that can fit into our understanding of what might have happened the first ultra millisecond after the Big Bang. I've been to CERN. I have to tell a funny story. We work at the Vatican, and our finance comes from the Vatican city-state. And the head of the city-state is usually a cardinal. So in 2009, Cardinal Loyola then had a friend, an Italian doctor, who had worked out how you could use very energetic protons in cancer cures and cancer research. And he wanted some publicity for this. So he invited the cardinal to come to CERN, where he was doing this work, and put a spotlight on this work so people would know about it. The cardinal invited the director of the observatory, then Jose Funes, who was from Argentina, and myself to go with him as scientists. He figured we'd like to, visit. Unfortunately, the day we arrived at CERN was the day that the movie Angels and Demons came out, which has as its plot about the Vatican stealing antimatter from CERN. And so all of the questions were about angels and demons, and none of it about the research we were doing. And that's one of the things, of course, that we do have to fight always, is the misconception of what science is and how science works.
Thanks, Hugh. I'll come to you. I've got a question here.
I've heard, well, first of all, I know nothing about astronomy and anything like that, but I enjoyed your talk. I want to know, is the universe limited? And is there any sense in the concept of a pluriverse. I've come across the word, but now with two experts, I'm delighted to hear the answer.
Well, science at that level is not about the answers, but about the questions. So if I simply say, we don't know, we have the summer school every couple of years. We're going to have one next summer. And I overheard two students talking. One was an undergraduate about to start graduate work, and the other, a new master's student who had just been an undergraduate the year before. And the undergraduate was asking the older student, what's it like being a graduate student? And the graduate student said, well, when you're an undergraduate and your mother asks you about black holes, you say, well, they don't really understand them very well yet. But when you're a graduate student, you say, we don't really understand them well yet. There is a limit to how much of the universe we can see. We can deduce from what we see that the universe apparently goes on beyond what we can see, but we're not sure, and there's no way to ever know how much further in this space-time continuum. Could there be other universes? And the answer is, I don't know. Whatever there is, God made that as well. Because God is not confined to this universe. How does Genesis begin? In the beginning, God is already there before any universe has been created. God is supernatural in that sense. Not like, a ghost is supernatural. If there were ghosts, they would just be part of nature. God is something other than nature who creates time and space and us, and creates out of love. So I'm not afraid if there's another universe, but I don't know. And if I can figure out a clever way to study it, that would be a lot of fun. And maybe 1,000 years from now, people would look at what I had done and laugh at me for being so naive. But that's okay.
So one word on a time. So one word on a time. So what is the time for God, really? So usually, the time is 1, 2, 3. So we have an axis, and we put a time there, and we know that we go toward the future or in the past. But actually, for God, time is always going to be there. And then for us, for God, actually, time maybe it's not the past, but it's the future. So what is going to happen? And then if we understand the time that way, that actually gives us hope. We know that, maybe things are not going well today, but that's not everything, because God actually, His time is in the future. God keeps creating. The creation actually has not stopped with us or with Genesis. So the creation continues. And then now we can explain, maybe sin. We can explain also maybe suffering, that actually there are a lot of suffering, but what actually all of that, when it comes to God, because we don't know what's going to happen tomorrow in God's time. And then that actually, open us to hope.
Here in South Africa, we have an asteroid which hit the Earth, I think, some 2.5 billion years ago, the Vredefort Dome. Is that of interest to yourselves as studying the universe? And if so, what interest is it to you? Thank you.
Right, that is something that I'm particularly interested in as a meteorite scientist. And in fact, there was a big meeting at the Wits about 25 years ago that I was part of. I went and got to see that impact site. And there's a large impact site in Arizona as well. As a scientist, It's very exciting because we have discovered in the last 50 years that impacts like that are something that has carved every planet that we can see. We didn't used to know that. When you and I were young, we thought that that was very rare. Now we know that's going on all the time, and here's a place where we can actually study to see how it happened. The material that you find is material from outer space. It's a reminder that cloudy sky overhead is not an impenetrable shield, but we are all part of that same universe. The Meteoritical Society, which met in Johannesburg that 25 years ago, is a society that studies both the meteorites and the impacts. And that's a very active part of research now. And just to give you a sense of how the Vatican Observatory is, considered in that field, we hosted a Meteoritical Society meeting ourselves at the Vatican a few years back. And for my sins, they've named me the next president of the Meteoritical Society. So for a very practical reason, we're very interested in these impact craters.
I've got a question here.
If physics and science continues to progress, do you think there is any aspect of God that will be measurable within like a scientific framework?
So the answer is no.
By definition, God is supernatural. We measure nature. And therefore, if you can measure it, it's not God. Is that right? I'm not sure. I'm just saying that off the top of my head. I'll probably think of an exception to that in half an hour.
Yeah. I mean, actually, it's a very good question. I said no. But we cannot actually bring God in nature. So God actually is above the nature. As soon as we bring God in the nature, we are not talking about God anymore. So is actually, I don't know, the truth is always before us. So we are going toward the truth. As soon as we bring the truth to what we know, so we kill it.
Another aspect to what you're saying, which is very true, is in the future we will know. Physics is not a closed book. Physics is not the answers in the back of the book. That's how we teach physics to our students. Get the answers in the back of the book and you get to go to the next course. But that's not real physics. Physics, a scientific paper is successful if it's proved wrong in 5 years. Because if it hasn't been proved wrong, that means nobody's bothered to look at it. We have to be incredibly humble about the physics we do because we know that we will use this physics to learn things in the future that makes this physics look naive. The same thing is true about our knowledge of God. And it's not that we're going to be finding out that what we thought about God was wrong, but that what we thought about God was naive. The picture I had from the sisters who taught me religion when I was 6 years old was naive. It's not that they lied to me. It's not that what they said to me was wrong, but that I wasn't ready to know the depths of it all. And maybe the best relationship is a relationship of love. If you have a close friend or a spouse, that spouse is not a problem to be solved. It's someone that you continue to learn more about every year that you're together. And you begin to realize how foolish you were when you first met each other and how much, we hope, more you know about each other now. I look at my parents who were married for 72 years and still, discovering things about each other when they were 197.
I have a question over here.
Yeah, question about the view of Galileo Galilei. I sincerely hope that it's very much part of your institution and his teaching, because in high school we have a dilemma. Tell me these days, these observations were phenomenal at the time. They were despised by the Vatican. Vatican has changed it. The data that he provided, are they still being used? Are they still being espoused and put down as challenges and postulations?
Everything you know about Galileo is probably wrong when you look into the history deeply. When I became a Vatican astronomer, I figured I'd better look this up. And so I've actually done a lot of research on this. Everything you know about Galileo is probably wrong, but the truth does not make the church look any better. We messed up. And we messed up because we're human beings, and it's the role of human beings to mess up. You have to remember, Galileo was an Italian, and Italians love controversy. He was also a Catholic, a good Catholic. His 2 daughters were both nuns. Of course, he never married their mother. He was an Italian Catholic, but still. Galileo was a genius, and he's someone that the Italians can be proud of and that the church can be proud of. And simply because he got in trouble with the church, so did, many brilliant cardinals at one time or another got in trouble with the church. When you look at Galileo's life, for most of his life, he was praised by the church. And then, for a very brief period in 1682-83, he was suddenly put on trial for reasons that even today the historians argue about. Some people say it was because he had insulted the Pope in his book, but the Pope had already been approved by the church. Other people say that it was involved in the politics of the 30 Years' War that was going on at that time. Whatever it was nothing about the church rejecting his science. You can read the transcript of the trial. The science never comes up. In the trial, it looks like they're looking for an excuse to find him guilty of something. At the end of the trial, the vote is 7-3 of the panel of 10, that Galileo was guilty not of heresy, but of vehement suspicion of heresy, which is a very odd thing to be guilty of. And when Galileo stood up and said, "I abjure everything in my writings that is contrary to the church," he never specified what those things might be, nor was he asked to. So it's a very peculiar kind of trial. At the end of the 19th century, when the anti-clerical government in Italy was looking for a reason to try to undermine the power of the church, they invented this myth of Galileo being a martyr to science, and they threw in Giordano Bruno for good measure. And in essence, they said, look at the church, it's old-fashioned, science will replace it. That was when the Pope said, we're going to have an observatory to show that we're not afraid of science, and in fact, we embrace science. So that's all tied into why we exist. The important thing about Galileo is that his science was wrong, in that he thought the sun was the center of the universe. It's not the center. His proofs that the earth was moving turn out to be wrong. And yet, he's right, the earth really does move around the sun. But the way he tried to prove it didn't work. And it would take a few hundred years. But remember what I just said. Successful science is science that turns out to be wrong because people have bothered to look at it more deeply. So Galileo was a very successful scientist that way. One last thing I'll say about him, and this is a lesson to anybody who teaches science. What made Galileo brilliant was not only that he observed these things, but that he could understand what it was that he was observing. When you look at Galileo's pictures of the moon, they look like a sphere with mountains. There is other people who drew pictures of the moon looking through a telescope, and they're like a circle with a bunch of squiggles, and they don't look anything at all. Galileo was brilliant because he not only knew mathematics, he also knew art, and he also knew literature. He was able to use his Italian knowledge of perspective to understand what he was seeing. He was able to use his understanding of poetry and literature to write it down in a way that other people could understand it. And so a successful scientist has to have a background in the humanities, has to have literature, has to have art, has to be able to speak in public the way we do. Galileo could do those things. And that's what made him brilliant and someone that we are all very proud of.
We'll take one last question.
Hi, thank you for the talk. You spoke of science bringing you closer to God, but in one of the questions you answered that if it can be measured, it's not God. So maybe I'm just misunderstanding, but can you clarify those two ideas? And then you spoke about the beautiful. How do you, as scientists, as empiricists, speak about the beautiful in a meaningful way that people won't dismiss you offhand? Thank you.
That's very hard to do. You're familiar with the story of Helen of Troy, and they say that she had the beauty of Helen of Troy launched 1,000 ships. So a friend of mine said, you obviously measure beauty in millihelens. That's the amount of beauty enough to launch one ship. It's ridiculous. You cannot measure beauty. If you can measure it, it's not beauty. And yet beauty exists. Truth. You can't say that something is 75% true. You can say that there's a 75% chance that you're somewhere near the truth. It's not quite the same thing. I think maybe the term meta is a better way of saying it. It is the sense of beauty and truth that underlies why we do the science and why we decide that one answer is a satisfying answer and another answer is not satisfying. There's the famous example given if you see a pot of water boiling on a stove and you ask, why is the water boiling? You could say the water is boiling because the heat from the flame excites the atoms and the molecules and they vibrate and so on and so forth. Or you can say the water is boiling because I'm going to make some tea. And both of them are true answers. Science is one of those answers. But with science, I'm able to make tea.
I think actually God talked about it, that science and religion, somehow even, the Pope, John Paul II actually put them in parallel. So science is here and the religion is here, and then both of them actually are running toward the same thing, and that thing is the truth. And that thing actually is a God for us.
Science is not the end. Religion is not the end. God is the end. Truth is the end. And if you worship science or you worship religion rather than worshiping God, you've missed the point.
Thank you, Brother Guy, Father Jean-Baptiste. Thank you for sharing your wisdom, your humor, your enormous knowledge with us. It has indeed been a privilege. So thank you very much. And safe home. God bless.